Continuing with number 14, finding the x-intercepts. I'm going to set y equal to 0 and solve for x. So I get 0 equals negative x squared minus 4x plus 5. If I multiply both sides by negative 1, I get 0 equals x squared plus 4x minus 5. The right-hand side factors to x plus 5 times x minus 1. Setting both of those factors equal to 0 and solving for x, I get x equals negative 5, x equals 1. Those are my x-intercepts. Negative 5, 0, and 1, 0. Okay, if I were to graph this parabola, it would look something like this. Number 15 was a word problem that said a firework is launched straight upward from a pool deck platform 6 meters off the ground with an initial velocity of 53 meters per second. The height of the firework can be modeled by the function f of t equals negative 4.9 t squared plus 53t plus 6, where f of t is the height in meters and t is the time in seconds after the launch. What is the maximum height? So you're looking at a parabola, and you know that this parabola opens downward. So the maximum height is going to be the y value of the vertex. Before we can find the y value of the vertex, we need to go after the x value of the vertex. So we find that by doing h equals negative b over 2a. So we get negative 53 over 2 times negative 4.9. That value, when I plug it in on my calculator, I get 265 divided by 49. Now I need to plug that value back in wherever I see a t. So I get negative 4.9 times 265 over 49 squared plus 53 times 265 over 49 plus 6. And that value is approximately 149.3. Number 16, given f of x equals negative 3x to the 4th times x plus 1 to the 6th times x plus 9 to the 5th, find the zeros, their multiplicity, and tell whether they cross or touch at the x-axis at that 0. So this one, if I set x equal to 0, that's my 0. The multiplicity is up here is 4. Since it's an even multiplicity, I know that it touches the x-axis. This one, when I set x plus 1 equal to 0 and solve for x, I get x equals negative 1 as my 0. Its multiplicity is 6. Since the multiplicity is an even number, it's going to touch the x-axis. Last, if I set x plus 9 equal to 0 and solve for x, I get x equals negative 9. My 0 is negative 9. The multiplicity is 5. Since the multiplicity is an odd number, it's going to cross the x-axis at that 0. Number 17, I know that I have a 0 at negative 1. I know that I have a 0 here at 2, and it's going to just touch there. I know that my end behavior, since this whole thing will resemble y equals, what would that be, 0.5 x to the 5th. So I know it's going to be down, up for my end behavior. When x is 0, I get y equals 0.5 times 1 cubed times negative 2 squared. 0.5 times 4 is 2, so my y-intercept here is at 0, 2. So I know I've got to go this way, and then I've got to come down and touch and go back up. So that is a very quick, rough sketch of this function. For number 18, for the polynomial f of x equals 4x cubed minus 29x squared minus 7x plus 98, if I'm given that 2 is a 0 and I want to write f in factored form, I'm going to go do synthetic division. 2 is going to go in my half box. 4, negative 29, negative 7, 98. Bring down my 4, multiply by 2, I get 8. Negative 29 plus 8 is negative 21. Negative 21 times 2 is negative 42. Negative 7 minus 42 is negative 49. Negative 49 times 2 is 98. It was a 0 because my remainder is 0. Now this gives me the polynomial 4x squared minus 21x minus 49. I know that that factors to 4x plus 7 times x minus 7. So if I wanted to write f in factored form, knowing that 2 is a 0, I get the factor x minus 2. Then I also have these two factors, 4x plus 7 and x minus 7. If I were to multiply all three of these out, I would get that polynomial. Number 19, given f of x equals 4x to the fourth minus 3x cubed minus 4x plus 22, I want to list all possible rational factors of f. They are of the form p over q, where p are going to be factors of the constant term, which will be 1, 2, 11, and 22, and q are factors of the leading coefficient. So that would be 1, 2, and 4. So if I put all of p over the first factor of q, being 1, I'm going to get plus or minus 1 over 1, plus or minus 2 over 1, plus or minus 11 over 1, plus or minus 22 over 1. Now if I put all the factors of p over 2, I get plus or minus 1/2, plus or minus 2/2, which I've already have, plus or minus 11/2, and plus or minus 22/2, which I already have. Now let's go do all the factors of p over 4. I get plus or minus 1/4, plus or minus 2/4, I already have it, plus or minus 11/4, and plus or minus 22/4, I already have. So all the possible rational factors of f would be from this list. Given this polynomial, f of x equals 4x cubed minus 13x squared plus 114x minus 130, if I want to write f as a product of linear factors, and I know that 1 plus 5i is a 0. Okay, I know that zeros come in complex conjugate pairs, so I also know that 1 minus 5i will be a 0. But that's only going to give me 2 zeros, so there's going to be a third 0 somewhere. I need to find it. So let's go start by putting 1 plus 5i in our half box. And I want to do synthetic division. So I have 4, negative 13, 114, and negative 130. I bring down the 4. Now I do 4 times 1 plus 5i, and that gives me 4 plus 20i. When I do the addition, negative 13 plus 4 plus 20i, I get negative 9 plus 20i. When I multiply negative 9 plus 20i times 1 plus 5i, I get negative 109 minus 25i. Now I do the addition. 114 plus negative 109 minus 25i gives me 5 minus 25i. When I multiply 5 minus 25i by 1 plus 5i, I get 130. Negative 130 plus 130 gives me a remainder of 0. Now I also knew that 1 minus 5i is a 0, so let's go put that in a half box. Bring down my 4. 4 times 1 minus 5i is 4 minus 20i. Negative 9 plus 20i plus 4 minus 20i gives me negative 5. Negative 5 times 1 minus 5i gives me negative 5 plus 25i. 5 minus 25i plus negative 5 plus 25i gives me 0. Okay, my factors. Here I get 4x minus 5 times x minus 1 minus 5i times x minus 1 plus 5i. Number 21, given f of x equals negative 2x squared plus 2x minus 3 all over x plus 2, go find asymptotes. The denominator, when I set it equal to 0, x plus 2 equals 0, subtract 2 from both sides, I get x equals negative 2. That's my vertical asymptote, x equals negative 2. I notice that the degree of the numerator is 2, the degree of the denominator is 1. So the degree of the numerator is bigger, so I have no horizontal asymptote. But I notice that the degree of the numerator is 1 bigger than the degree of the denominator, so I am going to have a slant asymptote. And how do I find it? I need to do long division. Negative 2x squared plus 2x minus 3 divided by x plus 2. X times negative 2x gives me negative 2x squared minus 4x. How did I do that? I did negative 2x times this, gave me this. Now I subtract. So I need to change the signs. Plus, plus, that's gone. 2x plus 4x is 6x. Bring down the minus 3. Now, x times what gives me 6x? And the answer is 6. So I'm going to do 6 times x plus 2, which will give me 6x plus 12. Now subtract. 6x's are gone. Negative 3 minus 12 leaves me with the remainder, negative 15. But I don't care about the remainder because the slant asymptote will be y equals negative 2x plus 6. You get that from right here. Number 22, given f of x equals 2x over quantity x squared plus 2x minus 8. Go graph it. First thing I did was factor the denominator to x plus 4 times x minus 2. There are no common factors in the numerator and denominator, so there will be vertical asymptotes whenever the denominator is equal to 0. So that's going to be at x equals negative 4 and x equals 2. You can see that I've already graphed those here on my graph. Horizontal asymptote, since the degree of the numerator is 1 and the degree of the denominator is 2, the degree of the denominator is bigger, so there is a horizontal asymptote at y equals 0, and I've already graphed it right here. Since there's a horizontal asymptote, there cannot be a slant asymptote. For the y-intercept, let x be 0. If x is equal to 0, I get 0 over negative 8. So I get the point 0, 0 right here. for my y-intercept. Now I cheated and graphed this on my graphing calculator, and I got something that looks like this. You could pick y values less than -4, plug those in, and you would see that they were all negative. So you'd know to graph it down here in this area.